In this lesson, we are going to be developing the most common type of search strategy. You have a specific chemical substance, and you need some specific aspect of that substance. You may want to go back and look at the PowerPoint on the sample chemical abstracts record, where you will see, and I've said this many times because it's so important, that every chemical substance is present only as its registry number. Only occasionally will you see the name of a substance. You need to get the registry number of the substance you are looking for and get it into the system. Just like the previous PowerPoint slides, what you type in is in bold type. What the system gives back to you is in regular type. And like the previous slides, these notes that I have in red are my own commentary. You won't see them anyplace else. It's mostly just emphasizing the things that I'm talking about. So you begin your search in the registry file, which we've looked at before, and you could look at the previous PowerPoint where you will see how to locate substances, either by their name, the molecular formula, by the registry number, and structure, which I'll be showing you later. It's different in STN than it is in SciFinder. We'll be looking at those differences. I am doing most of these searches in the learning files, mostly because it's cheaper than the full file. You can see how much they cost. I did it just to save money. In a real-life search, you would say file registry, not file L registry. I want to get the record for sodium chloride. So I say expand sodium chloride /CN. The /CN is necessary to tell the system that you were looking for this entry as a complete name. Whenever you enter the name of a substance exactly as it is in the database, it is always the third entry down. You see 2 up in the alphabet and about 9 or 10 down. Right underneath sodium chloride, you see another entry, sodium chloride, parentheses, NaCl. Can there possibly be 2 entries for this simplest of compounds? It was the first compound I learned when I took high school chemistry. We will see later in the next slide that this complication is resolved and how it is resolved. At this point, like in any substance search, I just want to get the registry number into the system and ready to search. So all I have to do is say search E3. I could have said search sodium chloride /CN, but it's much easier just to type an E number. Remember, if you are typing a long chemical name and you make a misspelling, you don't get what you want and you have to pay for that search term anyway. So again, always search the E number. It saves time, saves you money. This step that I've done here is totally optional. You do not have to display the registry file record for the substance you are looking at. When I said search E3, it locked the registry number in the system. I'm just displaying it just to give you an idea of what a record looks like. I've underlined the registry number. Further down, you see DR. That means deleted registry numbers. These are entries put into the registry database for a substance that did not appear at first to be sodium chloride. And you may be wondering, how can the editors of chemical abstracts be so confused that they did not recognize sodium chloride? And they assigned these registry numbers for a completely different substance, or what they thought was a completely different substance. This comes about because some people want to sell sodium chloride, and they don't make it clear that it is just plain sodium chloride. They give it some other fancy name. Later on, the people at Chemical Abstracts discover that, and they delete these registry numbers. The point is you don't have to worry about these deleted registry numbers. Just searching the proper registry number, the one at the top, will give you everything on this substance, sodium chloride. And if you look toward the top of the record, you can see why we saw more than one entry when we expanded on sodium chloride. Every 5 years, Chemical Abstracts in print came out with a different volume, and they would often change the standardized names of the elements and compounds. The most current name is sodium chloride, parentheses, NaCl. I don't see why that name is necessary. I think every chemist knows the formula for sodium chloride, but that was the last current name you saw when Chemical Abstracts was in print. Underneath it, you see in the 8th collective index, which was a different 5-year period, it was simply called sodium chloride. Before that, they just called it salt. The point about these registry file records is that you can take any recognized name for a substance. It doesn't have to be the official name, as long as it's a name that people use, and you will be able to locate your substance in the registry file. At the very bottom, they display the molecular formula of it. Anything under about 200 or 300 molecular weight size, they do display the whole formula of it. After that, they just say it's too big and they just give a name. Right above the molecular formula, you see that LC field. It means locator field. They're just telling you all the databases in STN that have information about sodium chloride. Most of these, as I said before, they're very specialized, and you don't really have to use them. You have to have a specific reason for using those files that they list. I don't even have the whole list here because it's so big. This slide shows the crucial step when searching for substances in Chemical Abstracts. You have already been in the registry file. You've locked the registry number in. Now you say file LCA, learning CA. In a real-life search, you would just say file CA. Search L1, which is the answer set in the previous registry file, means you are searching the registry number. Here in this learning file in Chemical Abstracts, there are 305 records that mention sodium chloride. Again, this is a very small file. The regular file would have at least 10, 20 times, or 100 times more than this. One of the shortcuts you can take, if you know the registry number, that's why we had that separate lesson on finding registry numbers. You can save yourself time. In the Chemical Abstracts file, in the CA file, you can just say search the registry number just by itself. I recommend you do not do this because in the real-life search, if you're in the Chemical Abstracts file and you search the registry number, you get a very complicated display. It goes back into the registry file, finds a substance, lets you know, and then eventually tells you how many articles are in the Chemical Abstracts file. I always recommend, if you do use STN and you have a chemical substance, it's always a lot easier and clearer to you if you start in the registry file. In this particular search, I just stopped right here. I'm not going any further. In the next series of searches, I'll show you what we aim to do at the very beginning of this lesson, find a substance and some aspect or property of that substance. But here I'm just showing you how to get a record for a substance, how many articles there are in the Chemical Abstracts database. In this search, which is the most common kind of search you will be doing in Chemical Abstracts, a property or some aspect of an element or a compound. Here we are searching on the purification of potassium chloride. I'm starting it the same way I started the search for sodium chloride. Again, I'm just in the learning file just to save money. Another purpose of the learning file is that if you do get an STN account and start searching it, until you get very experienced at it, You may want to run your search in the learning file just to make sure you're doing everything correctly. I'm starting it the same way I started the search on sodium chloride, expand potassium chloride /CN. And just like with sodium chloride, I see two entries for potassium chloride. One entry exactly as I entered it, and just below it, the entry that has the name with its molecular formula in parentheses. We'll see that these are really part of the same record, just like those two slightly different names with the same record for sodium chloride. I do the same thing I did in the other search, search E3, which locks the registry number into the system. As I indicate at the top of the screen, displaying this record is totally optional. Once you've done the search on the last screen, search E3, you have searched for the registry number, locked it into the system, and it's ready to search. I displayed this record mostly to show you that it looks very similar to the record for sodium chloride. When you are searching STN, ask yourself if you really want to display this record. It takes time and it takes money. Do you have a reason to pay for this display? Usually not. The first two steps are the same as we did for sodium chloride. I say file LCA. Again, in a real-life search, you would say file CA. Search L1 is searching the registry number. Every time you do a search, it gives you an L number. First search is L1, the next one will be L2, L3, and so on. The next step I do is search L2 with the S operator and the term I'm using for purification. Notice where I truncated it. I use the S operator to make the search more precise rather than and. I want to display just one of these records. So the command is display which answer set. It's L3. What format? All. And 2 just means the second one of these two. You can see at the bottom of the screen the registry number for potassium chloride is highlighted with the asterisks, and so is the word purification. This is what the S operator does. It links these terms close to each other, and it makes for relevancy. This article is clearly on the purification of potassium chloride. Remember, the index terms are entries put in manually by the people at Chemical Abstracts. It is their intellectual input. Here I am doing the same search, except it is in the full registry file and the full Chemical Abstracts file. I say File Registry to enter that file. I did not do expand potassium chloride /CN because I know its name. If you're 100% sure of its name, especially if it's a simple, well-known compound, you do not have to do the expand. Just make sure you type it in without any misspellings. Your next assignment will be similar to this. I will give each of you an element or a compound and ask you to find one aspect or one property of it. So these are the steps you will be following. After I locked the registry number in the system, in that first search, L1, I go into the Chemical Abstracts file, the CA file, and I say search L1, which is searching that registry number. The search at the bottom of the screen is a standardized way of searching. It is correct, where you take everything on potassium chloride, that 38,688 references, and how many of them also mention purification close to it. It comes down to 200. This is a correct search, and you can stop here. My aim in showing you searching, any kind of searching, is that you want to get every relevant reference on your topic. You don't want to be embarrassed by missing anything. That's why I'm just paraphrasing what's in red type at the top of the screen. The way these registry numbers get into the system is by people reading the article and putting them in. Occasionally, there may be some information about a compound or an element, and the editor may think it's not important enough to put an index term entry in. Also, the people at Chemical Abstracts, they're human, and sometimes they make mistakes. Sometimes there is something very clearly mentioned in an article, and there's no index term for it. That's what we'll be looking at on the next series of searches. Here I am showing you two other searches. One is correct, and one is a search you should never do. The search at the top, search, open parentheses, KCl or potassium chloride, close parentheses, S-purif, is a common mistake that a lot of people make. Even though it gives you more references than the previous search, it is a totally incorrect search. The reason for that is that you are not including the registry number. You're just looking for mentions of the compound somewhere in the title or abstract. In chemical abstracts, for any chemical substance, the most important mention of that substance is as its registry number in the registry file. You have to take that into account. So this search at the top is one you should never do. The one at the bottom, L5, is an option to the one search we saw on the previous screen. Instead of getting 200, I've gotten more than 1,000. I said search L2, which is searching the registry number, or its molecular formula, or its name, also closely related to purification. So which search is correct? Which is the ideal search? The specific one that gives you 200, or this one that gives you over 1,000? There's really no correct answer to which search is the preferred search. It depends on a lot of things. Do you have the time and the money to look at more than 1,000 references? Remember, you have to pay for each one. Or do you want to just focus the search and take the very specific 200 where most of them will be relevant? These are the kind of decisions you will have to make if you ever do have an STN account. What is your budget? How much time do you have? What I'm showing you on the next screen is a reference I got in this search, this L5 search, this expanded search, that was not in the more specific search. Here was just one record that's quite relevant. I am by no means saying that all these additional over 800 references that you get in this expanded search are relevant, but here is one that is. You can tell right from the title, purification of potassium chloride. It's very clear what this record, this is a patent, what is it is about. But as you look through it, if we just took the registry number and the S operator and purification, this record was not there. We'll see why on the next screen. You can see in this record there are several index terms that the editors at Chemical Abstracts put in, but none of these clearly have the registry number linked to purification. They missed it. When you are doing any search in Chemical Abstracts, you never know in advance how many citations, how many references you are going to get, but you have to have some idea of what you want to display before you go online and do the search. In these searches, I've just displayed just a full record for one item. You have different display options. You may want to take a look back at the previous lesson where we saw the different formats of displaying records and how much each one cost. Maybe you just want to display the first 10 titles. It's cheaper than displaying the records. In that case, you would say display the L number, space TI 1-10. that'll give you the first 10. That's just an option that you may want to consider. You can consider anything to display, but the important thing is when you do your assignment or whenever you use STN, have something in mind. Whenever you do any search in STN, you want to log off the system so you are no longer paying for it. The command is log off hold. If you just enter log off by itself, it'll ask you yes or no. If you say yes, you're out of the system, you've lost the previous searches. If you say no, you're back into the search, paying again. When you do log off hold, you are logging off, you stop paying, and it holds the search for you for up to 2 hours. Many times you are doing a search, you see what kind of results you get, and you need time to decide what to do, how much to display. Do you want to modify the search in any way? So when you do a log off hold, you come right back in where you were. You don't have to pay anything for the searches you've already done. Even if you are 100% sure that you are finished with the search and don't want to come back, always do log off hold. It doesn't cost you anything, and you have the option of coming back. Sometimes you may be working on a very complicated search, and you may need more than 2 hours to finish the search. All you have to do then is to log back into the system, very quickly do a log off hold, and that buys you another 2 hours. You can do that as many times as you want.